Alright, question 4 is transformations of complex locus from z plane to the w plane according to these transformations here. Right. So under this transformation, the circle given by a radius of 2 centered at 0 here in the z plane is mapped onto a circle C in the w plane. Right. So here I'm going to show you how they did it in the syllabus. Right. Okay. Now the first step is to rearrange these complex equations so that the z will become the subject. Right. So here you have w. Okay. Right, now from here you're going to rearrange that. Take for instance, I can rearrange it this way, horizontally over. It will be easier. Okay, that will be a z. Right? And then after you rearrange this, we can have our z. In this case, it will be 1 minus w. Z is equal to 3w here. And then therefore, from here, our z is given by 3w over 1 minus w here. Right. Okay, so I hope that is clear. And then after that, by taking a modulus both side. Okay, by taking a modulus, I'm going to write down here. By taking a modulus both side, we have this one here. Okay, and then we know that the modulus of z is given by 2. All right, so therefore, if we rearrange that again, that will be this. All right. Oops, I think I forgot to write these notations properly. It should be 1 minus w here. Right. Okay. Now, from here onward, you would be able to recognize that this is actually a circle equation. A circle equation, right? Now, the only thing that is challenging is we are not sure where is the center of the circle and then what is the radius itself. Now, the best way to discover the center and the radius of this circle is by converting it back to algebraic equations that we are more familiar with. So here I'm going to let our W equal to A plus IB, where the A, B are all real numbers, and then our I square is imaginary, which is -1 here. Right? So by putting this inside here, okay. Now modulus basically means the magnitude of that complex number A plus IB. So therefore, it's always best to square both sides. You get this one here instead. It'll be easier to work with. Yeah, for me, I think it's easier to work with the square than the square root itself. So from here, I can actually write down, don't forget, W square is just the magnitude of that complex number measured from the origin based on the Argand diagram here. So this is imaginary, real, and then our AB is somewhere here. This is B, and then this part here is A. Okay, so therefore the magnitude of this complex number measured from the origin here, and that is given by this, right? All right, so therefore this is given by A square plus B square equal to 4, and then if you rearrange this properly, we will have 1 minus A square plus 4B square. And then after simplifying this, we will get a 5A square minus, let me see what do we have again. This is minus become a plus 8A, 8A, and then after that you have your 5B square, and then finally minus 4 equals 0 there. And then we can complete the square for this. Right. If you complete the square, here just make it short. After you complete the square, you would be able to get a plus, let me see, that is 4 over 5. Is it 4 over 5? Um, 8 over 5, yeah, correct. 4, 5 square. And then this one will become a b square equal to the let me see, 36 over 25, right? And then which is the same as 6 over 5 squared here, right? Now, knowing that we have obtained this Cartesian coordinates equation that represent this locus here, now we know that this is a circle equation. This is a circle equation centered at these coordinates here, and then it has a radius of 6 over 5 here. Let me just roughly draw it here. So therefore, this is a circle. All right, so this is a circle centered at negative 0.8, 0. So negative 0.80 somewhere here. And then it has a radius of 1.2. So it has a radius of 1.2 there. So I would say roughly the circle will look something like this. Okay, forgive me for my poor drawing here. So that is a circle centered at the negative 0.80, and then it has a radius of r equal to 1.2. Right. So now there you go. Determine the center. So the center is negative 0.80, and then the radius is r equal to 1.2. Right. So I hope that's clear. All right. All right. Question 7. The point P represents a complex number Z on an Argand diagram, where it is given as such, and then where the point Q represent a complex number W on the Argand diagram where it is given as such. Right? Now find the exact coordinates of the point where the locus of P intersect the locus of Q here. Right? First of all, we have to recognize that this is actually the circle equation, right? This is a circle equation, right? Now, and then this is a perpendicular bisector equation. Now, if you are not sure, you can always let your z equal to a plus, or maybe it's best if you let your z in this case equal to x plus iy if x and y is more comfortable for you to work with in terms of Cartesian coordinates. You can also let w equal to x plus iy also. Now in this case, I purposely make it as xy is because they will meet at a common points. So when they meet at a common points, both their x and y must be the same here, right? Now I'm going to work out the locus for P to prove to you that this is actually a circle. So all we need to do is now consider this first locus. Now therefore we have z plus 1. Okay. Now there will be a x plus iy plus 1. Right, now it's always good to square both sides of them. Now, once you square both sides of them, you are actually getting the square of their magnitude, which is in this case is x plus 1 square plus y square. And then this part here will be 2x minus 1 square plus 4y square. All right, now I hope that's clear. Right. So from here onwards, you can simplify that, for instance. Okay, and then simplifying, we will have 3x squared. For sure, you have 3y squared then. All right. And then after that, you have your 6x, and then the 1 is gone. And then by completing the square here, all right, maybe it's better we just, oops, we just simplify this a bit. So you simplify this a bit, you will get 2x equals 0, like this. And then completing the square for this part here. Just complete the square for this section. That would actually give us this one here, x minus 1 square plus y square equal to 1. And then you will notice that this is actually a circle um, center with a center at 1, 0, and then radius of 1 unit. All right. So I hope that's clear. Let me show you how it actually look like. Okay. So in this case, you will notice that, oops, shouldn't use a Y instead. Should be using an Argand diagram. Doesn't matter actually. Argand diagram is just another label for that. So here I'll be using the standard notations that you'll be using. Okay, hold on, just let me correct that. It's supposed to be imaginary component. Okay, so that, let me write down that as an imaginary component. This one will be the real parts. Okay, and then this is a circle centered at 1, 0 somewhere here. This is a 1. Okay, with a radius of 1 unit. So this is a 1 there. All right. Now I'm going to draw the diagram more accurately in this case. So I'm going to get a shape to work with. It'll be much more easier. Okay, let me get the shape here. So it's actually a circle with 1 unit radius. So it's a circle. I just roughly say that it looks something like this. Would it looks more? Let me see. Okay, let me make it smaller a bit. So basically it looks something like a circle that has a center here and then a radius of 1 unit. So it has a radius of 1 unit here. Alright, so I hope that's clear. That's a circle equation. Alright, now next we're going to work out the locus for the second part, which is a perpendicular bisector. Okay, I'm going to erase all this. Alright, so I'm going to rewrite this equation here. This is actually x minus 1 square plus a y square equal to a 1. Alright. Now the second one, we're going to work out the locus for this in term of Cartesian coordinates that we are more familiar with. That will be x plus iy. So x plus iy also minus 1 plus 1 here. And then of course it's better to square both sides. So if you square both sides here, we don't need this anymore. So if you square both sides, you'll get this. And then for this one, we will get x minus 1 square plus 1 plus y square. And then if you simplify this, you will get x square minus 2x plus 1 plus 1 plus 2y, okay, and then plus a y square here. All right. And then you will notice that the x and y can be simplified, and then what's left behind is just x minus a y. X minus a y is actually equal to 1 after you simplify that. And then that is basically y equal to x plus 1. You notice that this is actually a straight line. Okay, so I'm going to draw this straight line now to show you how it actually look like in this case. So it's actually passing through negative, sorry, it passes through, let me see, oh, I think I write down the equations wrongly. It's supposed to be minus 1, sorry. Yep, this one's supposed to be minus 1. Oops. It's minus 1. Okay, minus 1, right? So if I were to plot this equation here, or sketch this equation here, it should look something like this. Oops, I take the wrong tool. You can see that my straight line does not really look very straight. Let me correct that. So it's supposed to be a straight line. Okay, let's see. It's going to take for a while to refresh. Okay, just let me work with this straight line shortly. Alright, I really need to get, okay, now here we are. I'm going to draw the straight line now. So that straight line would be passing through here. Alright, so you will notice that this is actually a perpendicular bisector for this line here. Right? So the perpendicular bisector for this line. So there is a point origin, and then there's another point which is 1, negative 1, which is here. So there is a line here. Okay, so this line is a perpendicular bisector of these 2 points here, or of this line that is given by these coordinates in this equation. Right? So that's the reason why this is a perpendicular bisector, 90 degree here. Okay, now you notice that the circle equations that we have worked out and the perpendicular bisector equations, y equal to x minus 1, would meet at 2 points here. Right, you will see that they would certainly meet at, they would certainly meet at point A and B here. Right, so that's what we are supposed to find out. Where do they meet? All we need to do is just solve these two equations simultaneously. Right, now I'm going to solve that now. So in this case, we will have, let me see, what do we have here? All we need to do is just substitute this one back into here. So we have x minus 1 square, and then that would also be x minus 1 square here equal to 1. And then you will notice that that will be x squared equal to 1 over 2. X minus 1 will be plus or minus. Therefore, x is equal to plus or minus of this. All right. And then for the y we will be able to get it from here. So when x is positive, then we will have 1 over sub 2. Yeah. And then y is negative. We will get, in this case, we will get negative 1 over sub 2. Right. So therefore, the coordinates of the points where the locus P and locus Q meet are given here. So the first point would be, you will notice that A is a positive number. That certainly would be this point. And then 1 over sub 2. Whereby point B itself must be these coordinates, whereby it's negative 1 over sub 2 here. Right? So I hope that's clear. I hope you are clear how to actually work out the point of intersections here, right?